Chapter 9, Unit. In the past chapter, we've dealt with z-scores, but there's some issues with z-scores. A z-score formula requires information that most times may not be available, such as a population standard deviation or variance. It's a paradox. You want to use a z-score to find information about an unknown population, but to know about that, then you must know about the population. So the solution is to use a corresponding sample value to estimate population standard deviation or variance. And then you would compute an estimated standard error based on sample data. So if we're going to use an estimated standard error, this means we can no longer use a z-test, but instead we're going to use what's called a t-test. So let's look at the t-statistic. The t-statistic is used to test hypotheses about an unknown population mean mu when the value of S is known. Let's look at a z equation versus a t equation. So we know z is equal to m minus mu over standard error, and t is equal to m minus mu over estimated standard error of the mean. So standard error versus estimated standard error. So the equation for standard error is standard deviation over square root of n, and the equation for estimated standard error is S over square root of n. So you can see these equations are basically the same. We're just using sample information. We're using an S for standard deviation instead of the Greek letter for standard deviation. And you remember your sample variance, S squared, is equal to SS over n minus 1, which is the same as SS over DF. You're going to be using that some in this chapter. And remember, for the standard deviation, you can actually just take the square root of the S squared if you have the variance already. So the estimated standard error is used as an estimate of the actual standard error. When the value of S is unknown, it is computed from sample variance or standard deviation, and it provides an estimate of the standard distance between a sample mean M and the population mu. And again, degrees of freedom describes the numbers of scores in a sample that are independent and free to vary. Degrees of freedom for a one sample t-test is equal to n minus 1. So let's look at an example. Let's say you have a sample of 9 scores and you're told that the sum of squares is 288. You need to compute the sample variance and the estimated standard error for the sample mean. So your step 1, the variance equation, S squared, you fill in what you know, and you should come out with 36. Then using that 36, you can find the estimated standard error. I would use the equation that says S squared over n, since we already know S squared, and then you find the square root of that. So you should find 2 as your estimated standard error. Let's talk about the distributions of the t-statistic. Let's talk about similarities to a z-statistic first, and then we'll talk about differences. So similarities, the z and t are both bell-shaped. They're both symmetrical, and they both have a mean of 0. For the differences, the t-distributions are more variable, so they're flatter and they're more spread out. And the t-distribution also depends on the degrees of freedom. So the closer that the t-distribution approaches a normal distribution, that happens when you have a larger value of the degrees of freedom, meaning a larger n. So a larger sample size for a t-test gives you a more normal distribution. So let's talk about proportions and probabilities for t-distributions. For a t-table, which I've shown below, I've shown the first 4 rows, the left column lists the degrees of freedom, and then there's 2 top rows. The first one at the very top lists the proportion in one tail, and the second row lists the proportion in 2 tails. So let's look at how we would find critical values. We would call these t-crit scores to put on our graph. So say you have an example and you're using degrees of freedom equal to 3, and you have 5% of the distribution in one tail. So alpha would be 0.05. You're going to read across on the degrees of freedom equal 3 row, and sometimes people might want to just put a piece of paper under that 3 row so they can easily read the numbers across. And then you're going to go down on the column where it says one tail of 0.05, which is going to be right there in the middle. And you're going to find a p-value, which is 2.353. Notice it's in orange. So t-crit for this test would be 2.353. Now let's assume that we have a two-tail. Let's assume this time that alpha is 0.10. So there's 10% in the tails. That's 5% in each tail. You're going to do the same exact procedure, except this time you're going to look at the second row across the top for the proportion in two tails combined, and you're going to find alpha equal 0.10, and you're going to read across from the df equal 3 row, and you're going to find the same answer, 2.353. Notice that in the t tables, it's just like the z tables, you don't have positive and negative numbers. Only your picture will tell you what's positive and what's negative. Then a two-tail, you have the positive and negative side. So notice that the total proportion of 10% in two tails is 5% in each tail. So that's why the same p-value applies as a one-tail 5% to a two-tail 10%. One thing that you need to know when you get to larger numbers, like say you had a degrees of freedom equals 53, they don't list all those numbers on the table. They might have listed a df equals 40, df equals 60. So you'd go to the lower one. So for example, you'd use df equals 40. You'd use that row to find your p-values. So let's do learning check problem 1. In what circumstances is the t-statistic used instead of a z-score for a hypothesis test? Well, the answer would be the t-statistic is used when the population variance or standard deviation is unknown. Let's look at learning check problem 2. The sample of n equals 9 scores has sum of squares equal to 72. What is the estimated standard error for the sample mean? Well, you're going to need sample variance or standard deviation before you can find the estimated standard error. So the sample variance calculation would be s squared equals ss over n minus 1. So fill in your information, you should have gotten 9. And then you have an estimated standard error now that you're able to solve, because now you know s squared, the variance, and you know n, to plug in the numbers, and you should find an estimated standard error of 1. Let's do learning check problem 3. On average, what value is expected for the t-statistic when the null hypothesis is true? Remember, the average of all t-distributions would be at t equals 0. Just like a z-score would be 0 in the middle, t would equal 0 in the middle. So your answer would be 0.